aha, ha, ooh, hee, ha, ah. And I thought my jokes were bad. How about a magic trick? I'm gonna make this pencil disappear. Ta-da! It's gone. And here we go.
I guess we should start here. This is one of mine. This is actually The Exorcist. So my buddy Steve owns the Demon. And my friend Ron used to own this amp. And then Ron never used this for whatever reason. And then I bought it back from Ron, and then I sold it to my friend Alex. And he's had it for 5 years or whatever, but he's now in the position where he's got to let go of it, and he decided to bring it here because, well, I built it, and let's face it, I've got a pretty large presence, I guess, and so it'd be easier for me to be able to go through it, recertify it, make sure everything's perfect on it, so that the next person that's going to pay the astronomical amount of money for this thing that it costs, because to build this amplifier today, I sat down and did the math the other day. For me to build this today with the parts that are in this box, it would cost almost $15,000. So it would be about $13,500 in parts to make this thing. So he thought it'd be best if he brought it back here and just let me take it apart, go through it, and check it all out and make sure everything's right and tight and ready to go with it for the next guy that gets to own this beautiful piece of work. I built 4 of these. I have one of my own that's way over there. My homeboy El Jefe over there in Texas, he's got one of these. We built this in remembrance. We built his in remembrance of our friend Mr. Black, Frank, and then I built these 2. This is one of the 2. My buddy Steve, Kingpin, or as the neighbors call him down there, Seaman Demon. Boy, they're brutal with each other down there in California. I'm here to tell you what, because they knew he bought the Demon amplifier version of this. Steve gets 9,000 on sideband out of his, and he has for 7.5 years. Alex doesn't quite have the electrical system, or had the electrical system that would power this thing full out. So this amp has been slow cruising with just like a 4-pill hitting it for the last 5 years, 4 or 5 years. And I think he was seeing 15,000 peak and like 8,000 bird out of it is what he was getting. I'm gonna go and look at this. Like, now I know I did a step-by-step how to build a 3CX 3000A7. I did a 3 or 4 part video series. It's like 9 hours long. I showed me hand making all the parts that are in these, and the whole logic behind why I put all the parts in here, and the logic why we lay the amplifier out the way we do, and the safety circuits that are in here, and why we've got glitch resistors and all this kind of stuff. I got to cover all that again in this video. I know a lot of you guys watched those videos. Some of those videos had 27,000 views, other ones had 14,000 views. They got a lot of views. So I know a lot of you have seen the build of this amp. Now, as I've been slowly talking to some of my friends saying, hey, I'm going to have one of these around, are you interested in buying it? I was shocked that nobody's seen that. Like, the people that I've been talking with here in the last couple weeks, because I knew this thing was coming and I was going to have to go through it, I'm just kind of putting it out there. Hey, I've got one of these coming. You might want to think about saving up your pennies because you know you'd be in the position to get one. They're like, well, I haven't seen any of those videos. shocking to me. So we're going to cover all of that as a basic footprint. Now, look, this is what happens when there's an unlimited budget with the builder, okay? As you guys seen, just here a few weeks ago from my buddy Don, I rebuilt a power supply for his Bojangles 3CX3000, right? Just rebuilding the power supply with the right parts took him from like 8,000 peak and like 3,000 bird to like 7,000 or 8,000 bird and like 14 or 15,000 watts peak, just by changing the power supply and getting the input tune of the box correct. So imagine, and that amp there was built within a budget, right? This is what happens when you don't worry about what the customer is willing to pay and you just build what you want to build and build it the best that you can. There's the power supply that's in this thing, this bit, this transformer is about almost 4 times bigger than what it needs to be. The whole idea behind this amp is that if you wanted to upgrade and change anything, the only thing you'd have to change is the head unit, the metal portion, the top portion of this. I mean, there's all kinds of trick stuff. When this thing's powered up, when you open the door, there's a little micro switch down here on the bottom of the door, down here in the bottom corner. Then when you open the door, it actually turns on a light that's right here so you can see what all the switches say. Right? It's the little things. It's the little things that make this really unique. But I do have to blow this out. I want to go over it. I want to check everything, measure everything, readjust everything. We're going to take the lid off of this. We're going to take the top of the RF deck off. We're going to look at the output side of the RF deck. We're going to make sure those relays are clean and ready to go for somebody else that wants to get it next. We'll put it all back together, put the sides on it, and run it. This is a whisper quiet amplifier. There's a bunch of sound dampening materials that go on the side doors. That's one of them over there. I had to take those off so I can move it around, right? It's on locking casters. I noticed when we were unloading the thing to bring it in here into the shop that the casters are all loose, so I've got to jack the thing up, tighten all the wheels up on the bottom, and I've got to basically go over it top to bottom. Make sure every nut, bolt, screw, and everything on here is right. Double check that the fans are all still working the way they should. You know, just go over it top to bottom. I doubt we're going to find anything wrong with this. I really do. Yeah, like the tune and load tuners, that tuner there and that one there, they come from Japan, and they're like triple ball bearinged. So you just touch the knob, just breathe on it, and they spin. Really, really, really high-end parts. This has got an iMac 3000 in it, not a Chinese tube. But yeah, gentlemen, we're here. I'm going to blow the thing apart, going to take the back off of it here in a second. I got to get everything cleaned up. Let's get after it, pitter patter. Let's take it apart and let's see what it looks like on the inside. I was sitting here taking the top off of this, and it dawns on me that the tune and load knobs are dusty as F, like really dusty. And it made me smile because I thought, man, we literally tuned this box out and then he never touched it again, which is really what you want. I mean, you shouldn't have to readjust your box all the time, unless you're jumping around on frequency like big jumps. The top side of this tube looks good, but that doesn't mean anything. We'll see. We will see. It took me over a month to build both of these. And I was literally working at it 24/7, it seemed like. So I built this amp, both of these amps, well, all 4 of these amps, pretty much the exact same way, and they're pretty much held together with a 632 Phillips, the resulting nut, and the 1032 screw, and then a bunch of big Phillips screws. So you could take this thing completely apart with a crescent wrench and a Phillips screwdriver and put it back together. The way the box is cooled, the tube is cooled, is unconventional from most train of thought. This is what they call a top cooled box. is you can see down the Teflon chimney that's in here, Teflon. Not, I got a Teflon cutting board and held it together with zip ties, like an actual billeted machined from a solid block of Teflon chimney is on the roof, the lid. Oh yeah. Well, none of this has changed at all. This is what I mean. That's our chimney, okay? Now we got sound dampening here to capture the noise of the blower. So the RF deck is completely pressurized. Air moves through the RF deck, goes through the tank coil, goes around the relay, the bypass cap, and then has to go down and come through the anode and come out the top. Please note, this box I think is 7 years old. Look at how good this looks on the inside. 7 years. Nylon screws holding the cut bezeled edges of the fiberglass board. I mean, I really tried to go all out building this. The tank coil. Look at how the tank coil's hooked up. Look at this. So I stress this all the time. I'm working with a guy right now where I'm teaching him about how to do tank coils, but look at how this is hooked up. Look at how the tuners are hooked up. The coil, there's no hard bent, looks all wonky kind of. This is how you get the most power out of whatever you're trying to make. So the tank coil's hooked up. Look at the interface surfaces between the blockers. Look at the strap that goes around the anode. No, that's not a piece of unknownium metal hose clamp holding it down. This is a piece of copper that was hand cut to the exact length it needed to be to go around the anode of the tube. That's 7 years worth of operation. Look at how clean that tube is. I'm going to take you around the backside here in a second and you'll see that all the lettering is still on the tube. I'm telling you, man. Surface area at all your contact points, especially on your tank coil. I cannot explain to you how important that is. There's our glitch choke. I mean, you're really hard pressed to find anything that's assembled this nicely today. Built by almost anybody. I'm absolutely tickled how well this is held up. That is beautiful. Beautiful, beautiful art. Here's the back side of things. Look, all the lettering is still on the tube. So I do a split deck cooling. There's a fan that's on the bottom side that actually cools the bottom side of the socket down underneath. There's no forced air drag loss between the top of the tube and the bottom of the tube. The bottom of the tube, the filament and all the leads and everything that's on the bottom side of the RF deck, they have their own fan and their own exhaust ports, so it's not cross-mingling of the air. So the air that's coming in here is nice and cool. It's not preloaded with heat from the bottom side. And then the bottom side's temperature is completely separate from the top side. It just works. It just works. So to change the tube out, it's not like pulling the tube out of a socket in the traditional sense, right? So it's not like unplugging the tube out of a socket and putting it back in. This is a 3CX3000 socket. It's physically bolted into place. There are some serious advantages to not using a tube socket. And there's some small disadvantages. So as you can see, we've got stainless steel washers holding on the lip seal, going all the way around the tube, and it's bolted directly to the floor of the amp. I discussed the pros and the cons of all of this. It's the little details, like even the back side of these screws aren't sharp. You know, I gone back and I hand filed all of them and deburred all of them. So there's no sharp hard edges on any of the hardware to prevent arcing. I mean, it's the little stuff like that. that makes a huge difference in performance. Huge. Wow, that looks really good. I want to take some pictures and brag about this now. It's been a long time since I've seen the inside of this amp, I'm not gonna lie. So let me show you what we're gonna do here real quick. We're gonna go in here and we're gonna take this file and we're gonna clean the contacts on the relay. We're gonna do that because this one takes the most abuse. If you quick key or short key, and I mean, this is where the rubber really hits the road, is on this airframe relay. This is a 80 amp, 28 volt relay. As you guys can clearly see, I'm utilizing both sides of the relay. So this whole armature thing coming down and splitting, the reason that this is longer on this side and this is shorter is to physically make it fit in the cabinet, number one, but number two, we want to use both sides of the relay. So if we take and we do math and we see that the RF is coming out of the cabinet over here on this little wire, and this contact tab is attached to this contact tab, right? This extra length of wire, if we straighten it out, and this shorter length of wire, the difference in the length is the same amount of distance here and the distance to the coax connector. So the RF wants to go across both poles of the relay when it closes. Brilliant, right? No, it's just simple. Let's use both sides of the 80 amp relay. Even though one side of this is technically enough to carry the power of the amp, why not use both sides? Well, for us to be able to use both sides, we have to make compromises like all this extra inductor here and less inductor on this side to be able to make it all want to come out of that side. Now, I'm not fooling myself and thinking that I'm some kind of mathematical genius. This side of the relay is probably taking a little bit more pressure than that. But we've tried to plan for the best, right? Prep for the best, or prep for the worst, plan for the, or pray for the best kind of thing. I'm really stunned how well the tube looks inside this box. So let's get in here and we'll lift up on this guy here. We'll lift up on this guy here real lightly. Oh, there we go. All right. Look at that. See, this is why we take things apart and we look at them. Look at that. Huh. You see what I'm looking at? This spring is missing. This little plunger, that there should be another one that's over here on this side. And here's the guts of it laying down on the bottom of the... Well, I'll be dipped in shit. Look at that. This does afford us the opportunity to do like a post-mortem on this thing. So when we took it apart, this is the way this tab was sitting, which is still functional, but we knew this wasn't right. So this cup and this spring, now I might have stretched this out a little bit when I dug it out of there, because my plan was I was going to do what I did from the word go. Anyhow, post-mortem. Let's take this spring off. We'll take this armature off. So what I was originally going to do was, I thought, man, I can take this top armature of the relay off, and then I can back these two screws out, and I can drop these two screws out and change just this top armature. But then I really got to thinking about it, and I'm like, I want to do this differently. So here we are after the fact, and this gives us the opportunity to look at how burned up the contacts are, which they're not. They're in really, really, really good shape for as much time as this amplifier's had on it. This amp was exclusively ran with a Sharky sequencer. So Sharky used to build this, Mud Duck Sharky used to build this little box that you could plug into. You plug your activator, it'd either be a, your pistol grip pile gun or your microphone or whatever. And it in turn would key your amplifier, key your driver, key your next driver, and then key your radio all for you, right? So looking at these contacts, it seems like I'm very overexposed. Here, we'll turn this down. Looking at these contacts, we can see that they're not scorched. There's really no arcing that's gone on the contacts whatsoever. So, hey, kudos to Sharky. So anyhow, how this works is there's a pin that goes through the top of this bar and allows there to be movement here. And then the bar, this bar here, goes through and then it's just staked over. So they come along and they hit it with a machine and they spread the ass end of the bar out, this pin. Well, that thing has worked its way out, right? Focus here, camera, not here. That little stake worked its way out. So I thought, well, is this something that I can repair? And I went, no, I'll never be able to trust this. And me being me, understanding that this is like $20 or $30 part, who cares? I'm like, who cares? Let's just go ahead and let's take it apart. Throw that right in the trash because I don't want any of those parts to ever get reused. And then it gives us the opportunity to have the deck out and really get to examine everything, right? So we already got the new relay in. Well, I built this thing so you could take it apart. I mean, stuff breaks, right? So I tried to plan for that in the design of these amps. I'm not gonna lie, you only have one opportunity when you first start building big or bigger. This isn't even that big. This is just a little 3000. You only have one opportunity to say, hey, this is what my skill set is. This is what I can do. And so I thought, well, let's not cut any corners. Let's hit this full bore with everything. And this is what I built. So the end result is maybe 35 screws later and about maybe an hour and 30 minutes. New relay. Never have to think about it again. Done, right? But I thought, man, this is kind of cool because I wasn't planning on breaking this down that far. There's no point. I want you guys to see something. This amp has been through 2 owners and has had a ton of airtime on it, like a ton. For those of you that think that bottom cooling a tube will never work, I present this as evidence. Let me show you how this is cooled. There's vents that are down here on the opposite side of the, this would be your filament choke, but it's an air wand. You don't have to have ferrite. On the bottom side of this thing, how this works, is a single little 120 millimeter fan. Right here. The fan sits just like this. And it just pushes pressure on the inside of the cabinet. That's all it does. And then up here on the top side of the cabinet is some more vents. I gotta put the lid back on this relay while I'm in here. Just like so. Goes on there nice and sexy like. It doesn't take a lot of airflow to cool the bottom of the tubes. Really doesn't. This is proof. If your inductor is too small, your wire, this starts to get discolored. If the eyelets weren't, if the whole bottom of this tube wasn't getting enough air, this copper would be discolored, this would be discolored, this would all be discolored. None of it is. This is all in pristine shape. This is overkill. Using this big of a ceramic. These are 1,000 picofarad a piece. There's one down here too, hidden down inside that inductor coil. But that's all it takes. Your filament choke, all you've got to do is make it so that the RF doesn't want to go this way. It wants to go into the tube. This is to help you isolate yourself from your AC voltage or DC voltage that you're going to apply to your tube. It doesn't matter, you can do it either way. DC is just a little bit trickier. You got to apply the bias on the ground side. And then you got to float the ground, but it's easy. And this thing looks like almost like the day I built it. Short for some dust. I mean, this thing literally looks like the day I built it. These little tabs here, they're what attached to these leads here. So if somebody does have to take it apart, it's already there. They don't have to cut no wires. Nothing has to be modified. It is. Man, I had so much fun building this. It was so stressful, but I had so much fun building this, and I am really happy that it still looks like this on the inside. But this is a good experiment. This has been, it would be off for 2 weeks, then run like every other night for 2 weeks, and then off for 2 weeks, and then run every, so it's had some talk time on it. Here's our end result. All right, I'm gonna quickly, let's put this all back together. This is one of the reasons I wanted to have this thing come here, is because, well, I want to be able to go through it, and then me personally, can sit there and go, good to go. And I get to stand behind it that way. If that makes any sense to anybody, it sure does to me. Okay, so let's go on down here, and let's take a look at the data tag. Where's my gain knob? There it is. So this is our data tag for this EPD. So the secondary on the top tap at 5,600 volts is 3.5 amps. Okay. Now on the top of this transformer, we have the ability to overclock. So we have 240, 230, 220, and 0. So we've currently got the primary set up at 220. Now, each tap adds 15% or takes 15% away, however you want to look at it. So on the secondary side, we're currently running on the 4,200 volt tap. That's the beauty of this transformer, is that you can make it run 2 threes, or probably 4 threes. And because remember, when you go down in voltage, you pick up amperage. The top tap, you can run everything in between. This transformer will run a 5,000, it'll run a 10,000, 2 sixes, no problem, with headroom. The 10,000, you can run it full out. So by changing the taps, the primary and the secondary taps, you can achieve all kinds of different voltages. So what we've currently got going on is the 4,200 volt tap on the top is overclocked by 30%. So post rectification, we got 6,213 volts underneath full load, which is good, because that means you don't have to drive the tube as hard. Now we've compensated for that overclocked voltages with a bias adjustment to get the heat out of the tube. And as we've all seen so far, obviously, it's working and the tube isn't getting damaged, right? Okay, I gotta show the data sheet for us to move forward. I've got the thing all put back together now. And so what I'm gonna do is I'm gonna hook it up and let it run for a few hours and just let the filament cook, because it's been a hot minute since this amp has been on. So give me just a second. Okay, blower on, filament on. And tube's heating up. I had to take this back apart. The blower intake, or the blower itself for the tube, wasn't spooling up. When we took it apart to replace the relay, I knocked one of the wires out of the starting capacitor block. There's a little distribution block that's on the bottom side, right next to the relay. Oh yeah, here comes warm. And it moves a lot of air. Anyhow, I knocked one of the capacitors out, so it wasn't one of the leads that goes to the starting capacitor, so it wasn't letting the blower start. So I had to take this back apart, reattach the wires, double, triple check everything, put it back together, Loctite some stuff. And then I also built this reinforcement rib to help keep this a little bit more stable as it's sitting here. Okay, so this is as far as I get for probably in the next 5 hours. And then I'll go and I'll put the lid on it, and I'll put the sides on it, and then we'll start testing the high voltage and getting that up. Also replace the RCA connector for the foot pedal. That down there. The one that was in there was plastic and I didn't like how it was looking, so I just went ahead and I replaced it with a brand new. Man, I'm going to get the word as soon as I quit doing the recording. I'm really tired. This has been a long ass day. You have no idea how long I've spent taking apart, looking at things, testing things with this. I want it to be perfect for the next person that gets it. So, yeah. Let's let it run for a minute. Tiffany style RCA connector. This is a heavy duty Tiffany style RCA connector. I don't know why that was so hard for me to think about just a minute ago. But yeah, Tiffany style RCA connector. I'm losing it. Yeah, but it can be as soon as I shut the camera off. Anyhow. So anyhow, while this thing's sitting here chooching along, let's talk about some of the parameters with it. This timer here in the front is for the soft start. And as we can see, we've got our conical glow coil here for the soft start circuit. We've got, normally this is the run of this diodes here and here would just be enough to do one leg of a 3000 for a single 3000. As you notice, there's 2 rows. The reason we do that is we've got one AC bridge on one side and the other AC bridge on the other. Once again, sticking with the theory of let's just spend the money once and have room for expansion into the future, I went ahead and built the rectifier board so that it was for the highest voltages that we could achieve with this transformer and with enough current that we could run a 10,000 no problem, or a pair of 6s, or 4 3000s. Let's go around to the backside real quick. This timer that's right here is the time off timer, and I've currently got it set very low. This is our 7,500 volt oil filled capacitor. This is our primary start contactor, and that's our secondary contactor for our soft start. Every single circuit that's in here has got its own connector back here. This is our primary bus. If you watch the Exorcist video, or not, pardon me, the Hellraiser video, that's the 3rd one of these I built for my buddy Jason Jones in memory of my business partner. I put this distribution in the front, but there are labels on all of these for what all the different circuits are, what they all feed, where they go. It makes it very easy for problem solving. The entire time this evening, I was so grateful that when I was having problems with this, I was like, you know, the beauty of this amp is that it's very easy to work on. You literally disconnect the high volt lead, you disconnect the filaments, you undo one 4-pin mic jack, disconnect the coax connectors that bring the RF in and take the RF out of the RF off the deck. You undo 4 screws and the whole RF deck comes right up and it comes right out. It's super simple to work on. I love this thing. Got our 35 amp power supply, and what that primarily runs are these fans, indicator lights, and a couple other little things in here. So I got a 30 amp switch module in here to power about maybe a half an amp worth of draw, right? Now the reason this is so loud is because the back is off, and we're listening to the whistle off the blower. That's the reason I have all the noise canceling and the foamed backs and the dynamatted this and dynamatted that. It's really quiet when this amp is running. If we get in here and we'll look, you'll see that everything has been hand tied. There's no zip ties in this amplifier. I mean, there might be 1, maybe 2, but 99% of this build, if you go back and watch the how to build a 3CX 3000 parts 1 through 3 or 1 through 4, you'll see that everything is hand tied. Everything is way overbuilt. for a single 3000. If you're gonna do something, like Doc says in Back to the Future, do it with some style, right? Why not take it to that extreme next level? That's what I'm saying anyhow. So here's the safety circuits for this, well, the metering, part of the metering circuits. This is set up so that I can put a grid meter in this at any time if somebody was interested in it. I think I've got one or two more of the meter movements, so I could make it match. But over here is our high voltage lead. This is what knocks down our high voltage, and then that goes on a piece of 50 ohm coax and goes up to the front. This is our amp gauge, believe it or not. So 100% of the ground current goes through this coil. The resistor acts as a balance, and by adjusting this resistor value, which happens to be 15 watts at 10 ohms, we can adjust the meter on the front. Some guys have put a little trimmer on it or whatever. It's not really needed if you get your resistor right. This fuse holder is the biggest thing out of all. I wish everybody would use this technology that I put into the videos on how to make your 3000 safe. And I'm using the same idea, same principle, same circuit on my 40,000. If anything goes wrong with this tube on the high voltage side, that fuse goes bink. It doesn't go pow, nothing goes boom, it goes bink. And it trips and pulls the contactors. The contactors go back to a little 12 volt relay that's here in the back. I can point it out to you here in a minute if it's necessary. The contactors go back to this relay. The relay is a sacrificial animal. If there is too big of a high voltage short, it'll blow the coil out of that little relay, but it protects your contactors. 100% of the ground for the RF deck goes through that fuse holder. So if there's a short, something decides it's going to happen in the high voltage circuit at any time, either the tube arcs out, pulls too much current, gets overdriven, it blows this relay. Bink. No bang, no big boom, no kaboom, just bink. The contactors come off, the bleeders do their thing, they pull the high voltage out of the cap almost instantly, and bam, the amplifier is safe. Now, us putting this on a fuse allows us to protect the tube. What do you mean by that? Well, instead of it blowing the circuit breaker, where the whole box shuts off, air stays on the tube. Air stays on the tube and cools the tube down. So the seals, you don't have to worry about the seals going bad. So if for some reason you're driving the holy ape rape bejesus out of this thing, okay, and the tube, let's say, is 150 degrees, 180 degrees, whatever, if something in the high volt circuit manages to fail, which I can't believe would because this thing's been running for 7 years now, but if something in the high voltage circuit fails, instead of it trying to go back through the tube, we just pull the high voltage away. Just snuffs it away. And the air stays on. So we're protecting the tube, we protect the seals. That's part of the circuit. The other thing that you have to do is you have to build a glitch resistor into the circuit, which is 2 resistors. So it's 1 fuse holder and 2 resistors on the high volt lead. High volt, you run maybe 1.5 ohms. Run all your high volt through that, which is down on the bottom. I show that in the build videos. So if there is a short or something does arc out, those resistors act like a shock absorber to the circuit instead of them physically failing, because when we say glitch resistor in most particular situations like SP220, you know, Kenwood 922A, those kind of things, there's a small, like 0.5 ohm resistor that's just a couple watts, and we put that on the ground side, and it blows open. And so it shuts down the whole high volt circuit. Well, we're doing the same thing with the fuse. But in this high power application, like what they do in transmitters, is they'll have a large resistor bank that 100% of the positive side of the current flows through. And so when the big electrical pulse comes to the system, instead of it trying to go back through the anode down to the cathode, all the energy gets dissipated in those resistors. 100% of your operation, that's why we use such a low resistance, high watt resistor, 100% of that electron flow, which goes from ground to hot, goes through those resistors. That's why we need such a high wattage resistor, but low resistance. It's just a slight lift above ground, just a slight bit of resistance to help protect the tube. That's why I say this amp's almost bulletproof. If the high voltage goes kablooey or shorts over or arcs out for some reason, it just blows this little fuse. This is a slow acting, high speed fuse. They're gray. They're made by the ABC company. This one's currently fused at 1.5 amps. So anything over 1.5 amp worth of draw, hard short by the way, because we can take a 1.5 amp fuse and surge it up to like 5 amps, no problem. That's how we can run it as a protection circuit for the tube in operation. But anything over about maybe 3-4 amps worth of draw, bang, fuse goes pop. It's not a violent degradation of fuse. It's not a rapid disassembly of any kind. The fuse is filled with siliconite and sand and whatever, and when it pops, the little wire that goes inside, instead of going a kapow, it goes pink. Very non-violent, very safe, very easy way to manage your high voltage. I covered all of this and how these are built in the previous videos. Please feel free to go explore them. I'm not going over all of that again today. All right, so we're gonna let this cook, and then it'll be time to put the lid on it, and it'll be time to put this back together. I have scrubbed, cleaned, wiped, polished, and shined as much as I can on this thing to get basically dust. That's the only thing that I've found so far on this thing is dust. Get the dust off of everything and make it pristine. The inside of this thing is spotless, as you guys have seen. I'm very happy with the current condition of this box. I think it's going to be great for somebody else. All right, so when we come back, we'll have high voltage on the tube and we're ready to check zero signal, which means we'll be ready to key it. Okay, so it's 2 a.m. and you decide that you want to go turn your amp on. Well, how do you know what switches do what? It's simple. Reach down here, you open the door, and guess what? A frickin' light turns on so you can see what's going on. How hard is that? There's all of your switches, very clearly illuminated for you. And then when you close the door, after you've turned on the giant high voltage death kill you machine, you just close it and it shuts itself off. Here, I'll do that one more time. On, open. It's the simplest things, right? It's just the simplest things, in my opinion, that make this thing special. Okay, so let's say you got grandbabies running around your house, or little kids. You're going to teach them that this is something that they don't play with. But I remember being a little kid. I don't know if you do, but I do. Somebody told me it wasn't allowed to be played with. I had to go play with it. You, as the owner of this piece of equipment, have yourself a dog tag. This dog tag says BBi Built, 3CX3000A7, right-hand door. You're going to find your dog tag, because on this dog tag is a key. You are completely locked out of this amplifier. There is no way, no how, some little chitlin is going to get in here and turn your stuff on, because you're completely locked out. Oh, but what about the sides, BBi? Guess what? Locked out too. Can't get in. Will not let you in. Take your key, put it in the lock, unlock the side. You can open the side of the cabinet. But you can close it up, and now the giant death murder machine is kept nice and enclosed and locked up and tight. Put the key in the door. unlock the key, turn the handle, open the door. You go to close it, let the neodymium magnet that's buried in the top part of the door pull the door shut, and it's all locked up again. Both sides and the back are this way. You can have this thing on, running, high voltage, and little kids can be running around it because it's perfectly safe. It's not a frickin' wood box with a pole peg in it. And you're praying to God the kids don't play with it when you're gone. You know that you're protecting your family and yourself. One of my friends has got one of these. He says the upside to the key is that when he gets drunk, his wife goes and takes the key and hides the key. And then it magically shows back up the next day. I'm not kidding you. Legit. So, let's go ahead, let's fire this thing up. Locked. Put the key in the door. Unlock the door. Now, how do we go about starting this thing? Well, we start from the top and we work our way down. So first we turn the amplifier on, and that turns on all of our fans, our blowers, and everything. And we turn on our filament, count to 3. 1, 2, 3. And we turn on our high voltage. Now that piece of tempered glass that the door is made out of, and this Lexan that's in the front, is what's keeping you from killing yourself. You cannot jam your hands in there in any way. All the switches, they work off of ground, but they only work off of DC ground. So the AC return and anything that could possibly even remotely electrocute you is hidden behind another relay or another contactor. Make sense? The switches cannot conduct high voltage in any way. It's a minimum standard. I remember I read a UL listing, Electrical Safeties Manual. You're not even allowed to, in the real world, not the CB world, but in the real world, have your tuners attached directly to the knobs. You have to have a 4-inch minimum worth of high voltage insulation material that goes from the back of the knob to the tuner, and that's 4 inches minimum at 4,000 volts, and for every volt you have to add an inch. That's for both sides, the input and the output tune, to help keep you from getting electrocuted. So how we got around that is we put that behind a lockable, safe, grounded door. Mic drop. How hard is that? Safety third, right? Safety third. Now, the meter on the front is precisely calibrated. I showed this in the actual build video for this amplifier. Yes, it's sitting at 6,200 volts. Why are we sitting at 6,200 volts? Because that's where it needs to sit, so when the tube is fully loaded and fully in operation, we're above 5,200 volts. The operating suggested voltage for the tube. Not, oh, it floats at 5,200 volts, but when I key it, it drops down to 4,000. What? No, I don't give a shit about that. When you look at something in the data sheet, when the tube's fully operational, the number that's on the data sheet is what you want to be applying to the tube. Not when the tube's resting, not when we're in a float situation. When the tube's fully loaded out, that's the voltage we're shooting for. And as we run it, I'll display to you that's exactly what's going on here. I was on the phone with a customer slash friend of mine tonight, and he was talking about how he's made a friend down where he lives. He just moved. He made a friend down by where he lives that turned him on to this new coax, brand new coax. Nobody's ever heard of it before. It's tan in color. He's like, man, this coax is amazing. No one's ever heard of it before. It's RG something or other. And I'm like, RG 400? Please note, this is a guy that's watched a lot of my videos. And it kind of took me back for a second. I'm like, what do you mean he discovered this? I just kind of chuckled and I'm like, dude, what are you talking about? That's what I use on everything. All my jumpers are RG 400 or they're RG 393. It's big brother. And then when we start getting bigger, we're talking like this. This is my coax that I run here at my place. right? We're putting in comparison. Just saying. It had me laughing. He had me laughing tonight. I was getting a little tired though. I had to let him go. But we're just going to drive this with the bench 4-pill real quick here in just a minute. I've still got to hook up a foot pedal and turn on all the meters. But for right now, what we've got going on is a 50-watt slug, and we're going to have to change these elements. That's probably going to be a 10,000 watter, that's going to be a 5,000 watter, and it's a 5-watt slug in reverse. I'm going to show all that to you here in the next clip. It's 4 a.m. I really want to get this shot. You guys are seeing something you've never seen before. The bird meters aren't here. We have a 100-watt slug in reverse between the 4-transistor LD MOS amplifier. I'm running that with the RCI 2950 at the moment. And the reason I'm having to do that is because, well, it dawns on me today that I need to build myself a bench 4-pill, or a bench 8-pill. I don't have an 8-pill for my workbench, and my 4-transistor amp just wasn't making enough drive. Just wasn't. The 2 previous owners that had this amp, they never drove it this hard. My friend Ron, that owned it initially, we drove it this hard when I first took it to him. And he's like, holy crap, what the, oh my God. And I'm like, yeah, that's the day that we let lightning bolts off the top of his antenna. But needless to say, I digress, it doesn't matter. We're gonna use this to kick the amplifier with about 1,800 to 2,000 watts worth of drive, peak. So we'll come back to that. What I do want to do is come over here and talk about this. So what we got going on here is the coax connector coming out, goes in a big rainbow pattern. It goes all the way around, goes into the bird light, and then comes out and goes into the dummy load over here, which you guys have all seen. So the numbers that I'm going to show you this amp doing is nothing special. But there's going to be some people that are like, what? I can't do that. Yes, it can. If you spend the money on the right places, yes, it can. I got this from Coaxial Dynamics the other day. This is a 25 kW, 2 through 30 megahertz element. Okay. I've been waiting to test this, and I'm tickled. As you guys know, this failed on video the other day. I had one of these that they sent me that failed, and I called them, and they sent me another one. They like literally overnighted it to me. Thank you guys at Coaxial Dynamics. So, and come to find out what was wrong with the other one is the little fingers on the side of the element weren't adjusted appropriately. So, still sealed in the plastic, just took it out of the bag. Literally, virginal. Okay. We're going to use the 10,000 watt slug here in a minute, but I just wanted to show you this, that notoriously the 25,000 watt peak element is a little bit generous. This will show you really good numbers, but then when we go back to the 10,000 watt element, because this has got an automatic doubler in it, it'll allow us to see basically the same numbers. So, okay, we're ready to rock and roll. Let's go talk on the radio. Open the door, turn on the fans, turn on the filaments, turn on the high volt, close the door back up. We're ready to go. So before we go any further, our coax temps are 73 degrees. Everybody can see that. The actual bird meters are putting out more heat than what the coax temp is. Now let's really get the cacophony of noise going. Let's get the 4-transistor LD MOS amp going. And let's zoom on in here for your video pleasure. Okay. Here is radio drive on a 25 kW element. Hello, 1111. Yeah, that really happened. Okay, here's the driver. Hello, 1,1800 watts of drive. Now let me make this really clear. This amplifier is 10 to 1, right? So every 1 watt you put in it, you should, in theory, get about 10 watts out, right? It's 100 to 1, pardon me. So if we put 1800 in it, we should get 19,000 out, right? At 1 1 at it's 20,000 watts. This is a 5,000 watt element right here. But I'd have the radio dialed way back, way back. So now, $7,000 watt dead key, no problem. Let's dial it back down to about a 3,000 watt carrier. Now I know RF is getting in the microphone. There's literally nothing I can do about it. I'm standing in the middle of an RF tornado at the moment. I got a 4,000 watt driver that I got dialed back to nothing, and I'm standing next to a 22,000 watt amplifier. Like, legit, okay? It's silly. Little 1 1. Something else, isn't it? At 1 1 1 1 at It can do more. I don't feel the need to put any more drive into it though. The most drive I've ever put into this amplifier was 2400. That's on the peak side. So that was a Striker going into, I think, a Henry desktop 3K. And then that was making like 24, but it won't run like that. You guys understand that this is an unsustainable number, right? The tube can produce the power, but the amplifier, or the tube can produce the power, but it can't get rid of the heat. So our exhaust air temperature is 103 degrees. Now let's look at our coax. Much hotter. Much, much hotter. We're up to 78, 80 degrees. I had it set up to where I normally would, where I have the 3000 sitting on the floor and the meters over here. The problem was that the coax was getting so hot that I didn't want it, like literally I put my hand on it. I'm like, oh, no, we're not doing that. And then you got to think from the edge of the cabinet over here over to the workbench, the meters are now in the middle of the coax, so it's not going to give us an accurate reading. It's just not. Let's go over here and let's take a look at input reflect. This is a 50 watt element. I said 100 watt earlier, but let's zoom in further so we can see very clearly it's a 50 watt element. So what do we got going on for pass-through tune? So that's the RF's ability to pass through. So here's radio, 1 1 1 1 1. Driver, hello, 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 hello. Perfectly flat pass-through tune. Here's our input tune. I gotta make sure to step on both pedals here. Hello, 1 1 1 1. Hello, 1 1. Hello, 1 1. I'd spend a little bit more time, I could get it down lower, but the whole point is that it's low enough that it's not going to make the output numbers read false, right? About 3 or 4 watts of input reflect with a couple thousand going in, right? Let's do this again. Hello, 1 1. So on the right is plate amps, on the left is plate volts. That's zero signal. Hello, 1 1. Pulling right out about an amp. And remember, on the top tap of this transformer, it's 3.5 amps. So we're nowhere near taxing this thing. And let's notice what the voltage is when it's fully loaded. At 5,500 volts. So it's not like we're juicing the tube. We're running 300 volts over spec. Just saying. I mean, these are real numbers, right? Okay. Let's see, where did I put my 10,000 watt slug at? Here it is, it's in the holder. So, $10 kW, okay? Now, like I was saying, everybody knows, and there's no heat coming out of this amp at all. It's crazy. As everybody knows, those 25,000 watt elements are a little generous. It's kind of universally known. I found that the new element is only off by about maybe 1,000 watts. I had a friend of mine one time that he'd run his 10,000 watt element and he put it on multiplier and it'd show him like 17,000. He'd put his 25,000 in there and it'd run over there. It'd make like 25,000 watts. So, about 1,000 watts. Notice the average numbers haven't changed. And once again, amplifier drive. That number hasn't changed really. So, blows me away is the 10,000 watt dummy load. We're putting almost double what it's rated for into it, and it's still down in the milliwatt range. So our air temperature coming out of the box, hopefully I got this in frame, I do, is 118 degrees air. That's it. No, it's not even that. 105, 103. 103. This is 115 degrees, the motor. And that's silly. Hello, 1 2 1 2 audio, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 audio, 1 2. I can only imagine what I'm doing to the microphone. Only imagine. I can't wait to hear this in post. It's gonna be. Oh, this is my favorite part of the drill. I'm starting to run up against a hard timeline, you guys. I'm sorry I've been a little grumpy in this video. I'm just running up against a timeline. I've got to get this amplifier done. It took me a lot more time earlier this week to get a bunch of other stuff done that I'm doing for the same guy. And we're finally here. I mean, we're finally here. It will literally do this. Hello, 1 2 1 1 all day long. Hello. Okay. I'm very curious what I'm putting into this 4 transistor unit to get this 12,000, 1,800, 1,900, 4,000 watts, whatever I'm getting out of this for drive. Let's see what I'm putting into this. This is just a radio. Hello, 1 2 1 2. Man, I don't know. I'm really tempted to hook up the D-Rail Cobra 29. Let me hook that up. I wonder if I can get the same amount of drive out of that radio. Hold on. This is going to make this 3,000 jump. Okay. 16 peak watts, right? Whole lot more bird though. Driver amplifier. Audio. It's roughly the same amount of drive. $10K. $10K. Please don't blow up my friggin' 4-pill LD Moss, precious, beautiful, I love you more than anything in the world amplifier that's still up for sale. Audio. So 18,000, no problem. Let's bump this up a little bit. Okay. 6,000 bird, 18,000 peak. Well over 19,300, and I didn't look at the average. 7,000-ish bird. That's 11,000 watts carrier. Dial this back down. Okay. Reason that's important to show is most of the old timers that are watching this are thinking, man, he's not going to throw a big ass carrier and just let it hang there. Just made it do 11,000 bird dead key. $12,600. Look, those numbers are fun, right? But you don't want to run there. Everything gets really hot at that point. Here, the coax is up to almost 100 degrees. Our exhaust air temperature, now we're actually seeing something, 153 degrees. Hold on. Come here. Well, I just shot myself in the foot. I was trying to turn the screen around so I could see it, and I knocked the battery off. So, 128, give or take. Focus. 124. Just goes to show you with the right size power supply and the tube biased properly, we're not stripping a lot of heat. We're not having to do an awful lot, right? All right, back to radio and amp drive. Hello. Back this down. Hello, audio. Hello, audio. No problem. Hello. Okay, let's have some more fun. Let's go back to the 25,000 watt slug. 25 kW slug, the brand new one, by the way. Hello, 1 2 1 2. Hello, 1 2. Time for me to grab a thumbnail, yo. So the whole point behind this box is that I wanted to build the most badass standalone by itself 3000 that I could. And I did it 4 times in a row, and they've all run the same. And they're all out there running just like this. Hello, audio. It's the thumbnail for this video. And I took that at the end of things, when everything's hot. Look, your coax connector, because it's a PL259, will melt, right? Your connections and stuff are going to start to break down. So don't run it at 10,000 watt carrier. Back it up, bring it back to 3,000, 4,000 watts and let it swing forward a whole bunch. Why not? Believe me, they ain't gonna hear you any different if you're at 3,000 versus like 6,000 or 7,000. They're not. It's just not gonna happen, right? Hey, we're finally over a watt. Hey, yes. I got a connection getting warm. Or the dummy, oh, the dummy load's screaming. Dummy load's 130 degrees. Hold on. Power of the Rotrons. It's the same fan that's here. There's 4 of them on the bottom of the 10,000 watt dummy load. I've never had to turn those on before. Look at this. It automatically turns on when it gets to, I think, 180 degrees. The connector's getting hot. I mean, like, for real, we're passing 21,000 watts through a PL259 connector. Either I'm silly and stupid and just zingy on the inside, or I like flirting with the devil. I say I like flirting with the devil. 1, 2, 1, 2. 1, 2. 3 whole watts of reflect. Okay. So we just beat the bejesus off this poor little thing, right? So now let's talk about shutdown procedure. This is all you got to do. When you're done talking on it, shut your high voltage down, shut your filament down, shut the top switch down, and you're done. Close it up, lock it up, walk away. You're like, but BBi is still working. It's still on. That's right, because it's got an automatic shutdown circuit on it. This amp, no matter what you do, will run for 5 minutes before it shuts itself off. The fans will sit here and chooch away, and that's based off an average number. So running the amp like this, as hard as we can get it, watching the air that comes out of the tube, getting the thing as warm as we possibly can get it, and then shutting the filaments off, shutting the high voltage off, and then letting it cool down. We did that 10 times. I did that on video in the previous segments, and we figured out roughly that on average that takes about 5 minutes to get to 0. There is a thermal thyristor that's built into this guy that trips the timer. So if the exhaust is too hot, like let's say we're putting 180 degrees in here, anything 150 and below, 5 minutes. It's simple. Why not? Now you guys have watched me move around this thing, touch it, feel it, fondle it. Okay? I'm not scared of this amp at all, and neither should you. Why? Because it's safe. It's all inside a grounded cabinet. Unless you're doing something really silly, you can't get electrocuted or hurt by this thing. And that's what allows me to sleep good at night knowing that you are safe. Let's give it just a minute. I want this thing to shut down, then we'll sit here and we'll talk some more. 81.5. So it's cooler than that on the inside. Now, with all that heat going on that's getting shot directly at the top of the cabinet, a guy's got to ask himself, what exactly do we have going on for cabinet heat? Well, here's your answer. If you'll focus, camera, here's your answer. 86 degrees. When I was a young man and I was in welding class when I was a kid, I had to spend a year doing doing exhaust systems. And because I was really good at heliarcing and welding, hood, gas, welders. I ended up spending another 6 to 8 months standing on one foot and welding together custom stainless steel exhaust underneath classic cars in my welding class. And I learned about the heat shield principle, how you can take one piece of metal and offset it just a little bit from your heat source. And on one side you can have blazing hot devil's anus heat, and on the other side you'll have almost nothing. On the inside of the lid, I took another piece of aluminum and I offset it by about 1/16 of an inch. Now you can't really see it because I've got sound deadening material all on the lid covering the offset, because the tube is actually right about here. It's just right about here. The reason the top of the lid doesn't get overly hot is because of that air gap that I left, okay? I'm really proud of these 2 amps, and taking into account I built them so long ago, I'm kind of out here talking, saying, hey, look what I've done. Because I think people forget that this is the kind of AC box that I like to build. I've got a 15 and a 40. I've got a 6000 sitting over in the corner. They're all built like this. There's no reason. The difference, the real dollar to donut difference, if I was to use Chinese, because there's no Chinese parts in this for the most part, the power supply, yeah, the power supply. Everything else is an American sourced part. Maybe, no, the fan on top says made in China. Everything else is an American sourced part. If I was to use all Chinese parts, okay, Chinese knockoff tuners, Chinese tubes, Chinese relays, all the Chinese crap, right? That only shaves maybe $1,200–$1,500 off the cost of the box from the way this sits now. This is all American stuff. American tube, American. It's got E.F. Johnson tuners for the input tune, for God's sake. Not that knockoff stuff that's on eBay now, right? To build safe like this, so we don't have to worry about anybody dying, like there's no way a necklace can drag on anything and anybody can get hurt. You can take your junk and rub it all over the back of this amplifier with it plugged in and on. And there's no high voltage lead that's exposed for you to get electrocuted and die. At the end of the day, a 2-piece unit is saving yourself a couple grand worth it? I don't know. I'll tell you this, I know for a fact that if I was to build this amplifier today, I'd have probably 13,000 to 14,000 in parts in this box, because it's all American parts. Now the thing is used, right? We know this. When my friend Alex bought this thing, he paid pretty close to $11,000 for it, okay? After it was said and done, because he paid me to bring it to him and all that other kind of jazz. The replacement cost of this is much more than that today. So we feel very comfortable asking, once again, $11,000 for this box. It is what it is. The Ultimo cheap seat to the Super Bowl. The upside is you've only spent your money once, so when you're ready to upgrade, all you got to do is buy the tubes that you want to run in this thing, and we change the deck for the most part. Depending on what tube you run, we might need to go to a different filament transformer, but I highly doubt it. I tried to really plan ahead for this. So, if you guys are interested in this, you all know the number. I mean, I think everybody in the friggin' radio world's got my number at this point, but if not, there it is. You guys have never seen the bare wall before, have you? Look at this. Let me move the camera over here. That's my coupler. It's just a bare wall, you guys. I've never shown that before on video, I don't think. All right, it is almost 5 o'clock in the morning now. And I got to edit all this tomorrow, and plus I got a ton of stuff going on tomorrow, and I got to look at my friend's 8-pill, which I opened that tonight, by the way. Homie, size does matter. You'll get the joke. I'll show it to you guys in the next video or two. You guys will see. Look, if you need me, if there's any questions I can answer for you, anything I can help teach you or share with you, or you got a question and anything that I can do to help, don't hesitate to reach out. Super shout out to my homeboys down here in the Patreon group, these guys. They're the ones that allow me to sit here and do these hour and a half long videos for you guys to watch. Otherwise, it'd be literally like a peek and tweak video. All right, here's your amp. This is what's broken. Okay, I'm gonna go fix it. Oh, look, it's all fixed. We did all the upgrades. Cool, have a nice day. Try to make the content entertaining and fun. If you've gotten anything from this video or anything else ever, you might want to think about coming and joining us on Patreon. We have a lot of fun in there. It's an open book. Everybody can talk about any subject they want. Right now there's 7 or 10 different YouTube videos that are out there that aren't here on YouTube, nor will they ever probably be. The coolest video I got out there is a 2-pill that I dead key at 700 watts for, I think, 7 minutes, 8 minutes on FM that hasn't been released to the public because we're doing some testing on some new fun products over here. I just want to say thanks to every single one of you guys that are going to choose to watch this. Thank you honestly from the bottom of my heart for being here and supporting me, giving me a thumbs up, showing me a little bit of likes, some comments down in the doobly-doo below. I say thank you. And on that note, my ass is out of here and I'm going to bed because I'm freaking whooped. I just wanted to get this done. And I appreciate you all hanging in there with me. If you're interested in buying this thing, give me a call. On that note, gentlemen, I appreciate you all. I'll see you. Click, click.